Hello everyone, as you know I am Paul, your e-hobby guy. Have you ever wondered if someone was going into your personal property without you knowing? Have you ever wondered if someone was stealing your food out of the refrigerator? Or perhaps you were wondering if your kids were stealing your booze out of your booze cabinet? This week's project will alert you when those things happen right away. So stay tuned and let's jump right in. We are going to start out with this device. This is a photoresistor. A photoresistor changes its resistance value based on the intensity of the light that it sees. Here is the photoresistor hooked up to my ohm meter. As you can see, the resistance changes as I shade the component and as I expose it to more light again. Its value changes from about 0.6 kiloohms to over 2.2 kiloohms. If I put this photoresistor in series with another resistor and put a voltage across both of them, the voltage drop across the photoresistor will vary according to the intensity of the light that is being exposed to. So I set that up right here. As you can see, there's two resistors, one photoresistor and one other resistor. I put a voltage across both of them. And as the intensity of the light changes as I shade and unshade the photoresistor, you can see the value of the voltage changing up and down. As I've covered in other videos, once I have a varying voltage, we can set up a specific reference voltage that will trigger an output from a comparator at a specific level that I want it to trigger. The reference voltage can be achieved in a similar way by just putting two resistors in series and choosing the values such that I achieve the reference voltage that I want for the trigger that I'm looking for. Jumping ahead a little bit, here I have a horn strobe. This horn strobe is rated between 12 and 24 volts DC. I'll check it out and see how it performs with 9 volts DC to see if it's something that I can use. Actually throwing this one away myself, and I decided to keep a couple to see if I could have some fun at home making some noise. Here we go with the 9 volt test. Let's give it a try. As you can see, this works very well at 9 volts, certainly acceptable to me. I don't particularly like the red color or fire because that's not its purpose, so I think I'll just paint it black. So with this in mind, I sketched up a circuit using the principles we talked about. Two in-series resistors, one of course with the photoresistor, both of these going in to a comparator, the comparator triggering a MOSFET to handle the power to drive the horn strobe. Okay, we'll do a quick review of the circuit I came up with here. There's two voltage divider resistor pairs here. One pair here and one pair here. The voltage between these two resistors is acting as the reference voltage, and the voltage here is going to vary because of this photoresistor and the varying degrees of light intensity. With this fixed voltage here and a varying voltage here, when this varying voltage drops below the fixed voltage, the output on this comparator goes from low to high. When it does go high, it triggers this N-channel MOSFET and applies a voltage of 9 volts to the horn strobe and switches the horn strobe on. Here's the circuit breadboarded. It is a little crazy, but I will try and just walk through really quickly. I took the cover off of this just to paint it black like I said I was going to do. And zoom in a little bit here. This black tape is the photoresistor. I put a black tape over it because I want this to activate when this whole device goes from a dark place into a bright place. It's dark right now because I have it fully covered over. These two resistors are the varying voltage divider pair, and these two are the fixed voltage divider pair. This chip is an LM339 quad comparator. I'm only using one of the four comparators because I only need one. The blue wire is the fixed voltage, the brown wire is the varying voltage going into this quad comparator, of which I'm only using one of the four. This resistor is connected to the output of the comparator that I'm using from this chip, and it's coming over here. This is the N-channel MOSFET. It's in the TO92. It's a BS170 MOSFET. I'll have the datasheet linked in the description below. So I've set my power supply to 9 volts. I've wired this up. Let's give it a try. So we can see here that when it's dark, the horn strobe is off. When it is exposed to light, the tripping threshold can be varied by varying the resistance that is in the voltage divider circuit with the photoresistor. We can also vary the reference voltage if we want to by varying the 2 resistors in the other voltage divider circuit. Here is a reed switch. The reed switch is normally opened, and when it comes in close proximity to a magnet, it closes. Let's hook up my meter. It's open. Let me just bring this set of magnets. You can see that it closed when the magnets got close. If this is mounted inside of a housing, I can use a magnet to activate this switch to turn power off to the system until I'm ready to turn it back on. What we have to think about next is how to achieve the 2 to 3 second delay that I'll need to activate and deactivate the system when I'm putting it into its destination or removing it from its destination. To simplify things tremendously, I decided to go with an Arduino Nano. With the Arduino Nano, I can hook up the reed switch as an input, and if there's a magnet present, it will tell the Arduino Nano to send an output that will kill the power to the siren. Here is the sketch or program for the Arduino Nano. I'm using pin 6 as an input pin and the output pin as pin 7. It is a pretty simple sketch. I will of course have a link in the description to download this. I wrote this program myself, so there's probably plenty of opportunity for improvement. I commented every single line to make it easy to understand. Here's the Arduino Nano interfacing here with my original circuit. You can see the reed switch right here. This black piece of tape right here is still covering the photoresistor. So I'm going to uncover the photoresistor to the reed switch. So now you can see the magnet shuts off the circuit. In addition to that, the magnet, because of the program that we went through, gives us a delay before it activates the siren. 1, 2. This shows how the magnet, in conjunction with the reed switch and the delay properties that we can just write into the program for the Arduino Nano, can work with this analog circuit up here in controlling the siren in the way that we want it to. It's time right now to hardwire this onto some perf board. My process for soldering everything neatly onto the board is pretty straightforward. I do just mount a few components onto the board so that I don't have too many legs sticking out at the back. It can get difficult to reach if there are too many legs sticking up. I do leave the legs on. Later they can be used as interconnect wires. Anything that is mounted off the board, like the Arduino or the reed switch, the wires are attached to the devices first and then soldered onto the board. Here is the reed switch. Okay, I just want to take a quick look at the circuit here, that it's complete, it's built. We made some interconnections at the back here. I just wanted to show you how I interfaced some of the items onto the board. I cut these female to female jumper wires in half to make the interconnections with the Arduino Nano. So I have red and black for the power, and one wire for pin 6 as an input and one wire for pin 7 as an output. And so there are a lot of available inputs and outputs still left on this. Of course, the photoresistor is mounted off the board because this is going to get mounted into a housing. Haven't figured out yet what I'm going to do there. Of course, the 9-volt battery lead clip, I just have it clipped into my power supply for now, but it will get a 9-volt battery. Also the reed switch with the magnet right next to it now so that we don't get any noise. I have to say I did try this, and the first time I powered it up it worked. And for those people who do build circuits like this, you know that rarely happens. Removing this magnet, does set it into alarm. It gave me the delay that I want so that I can arm it a few seconds after I put it down and close whatever door. I do see red in the back of this, so maybe I'll spray the back of that with a little black paint so it's more consistent. I'll get all of the circuitry into this box. It looks like I'll fit it, this board, the Arduino Nano, and a 9-volt battery. With that in mind, we'll move forward in getting the hole built here into the box. So I started out by marking for a hole to cut out so that I can mount the horn strobe. Then I measured the diameter of the photoresistor, which came out to be 0.2 inches or about 5 millimeters, and I drilled a hole in the housing for that. It should fit quite nicely right there. As you can see here, I secured it with some hot glue. Next, to secure the reed switch, I did the same thing and applied a heavy amount of hot glue, as you can see right here. I fed the wires through the project box, wired it, and then I just hot glued the horn strobe to the project box, just like this. Well, now it's time to give it some power, close up the box and test it out. But before we do that, I wanted to mark out the optimal place to put the magnet so that it activates the reed switch. This way I wouldn't have to be guessing where to put it. And so I marked the spot and I glued on one metal black washer in the exact place where it has to go. So this is the exact place the magnet will go to activate the reed switch. For protection, I put some black electrical tape on some stuff, and then I was ready to stuff it all into the housing, and let's have some fun. Just in case anybody was wondering, I do have a link in the description below to this schematic. I should point out one thing here. I did replace one resistor with a variable resistor, a pot, a 10K pot, and here you can see the photoresistor. So it's the resistor that's in series with the photoresistor. This allows us to adjust the sensitivity, or when the level of light trips siren to come on. Let's check it out in this drawer. Now let's check it out in the refrigerator. And of course, most importantly, in the booze cabinet. Before we wrap up, I just want to talk about a couple of things. I intentionally did not integrate everything into the Arduino, and so I'm throwing that challenge out to you. You could do away with the comparator itself and put the photoresistor directly onto inputs that are unused on the Arduino and read the values in that way to set the output trigger. Also, you could just use a barrel jack connector if the device was going to be permanently in one spot, in a drawer or in a personal safe or something, and just permanently plug it in instead of use a battery. Also, you certainly do not need a big horn strobe like this. You could just use a simple piezo buzzer and it would take a lot less energy, and your batteries or your power supply would last a lot longer. In closing, I'm glad you took the time to watch this video. Please rate it up. Subscribe to my channel by clicking the circle with my picture in it. Follow me on social media. I'll see you next time.